In this example we are going to get e to the minus 2t times ut convolved with e to the minus t times u of t. Here's our formula for convolution. So our first function is f, and we have to get f at t minus x. So we replace t with t minus x in our first function, which is e to the minus 2t times u of t. Then we must multiply by g of x. So our second function here is g of x. So we just replace t with x. Now, as a reminder, u of x equals 1 when x is greater than 0. It's equal to 0 when x is less than 0. U of t minus x is equal to 1 when x is less than t. It's equal to 0 when x is greater than t. I explained why that is so in a previous video. If you want to check it again, we know that ux equals 1 for x greater than 0, so you can replace x with t minus x and you'll get t minus x greater than 0, which will lead you to x less than t. So anyway, I won't go through that again. We can see that for values of x between 0 and t, both of these step functions are equal to 1. So when we multiply this by this, we just get 1. It's just 1 times 1. So we can just drop these u's. So this is what we get for the situation where t is some positive number. Now, as I've explained before, if t is negative, t is somewhere here, then we see that u, this function, is 0. So this here will equal 0 if t is negative. So the entire integral will be 0. So the convolution is 0. So we can forget about that situation. We're only interested in this integral for positive t. So this power is going to be minus 2t plus 2x, and we add this power onto this power here. So we get plus 1x minus 2t. We are integrating with respect to x, so when you integrate e to the power of something, we just get it back. But then we need to divide by the coefficient of x, which is 1. We treat t as if it's a constant because we're integrating with respect to x. Okay, we apply our limits. We plug t in for x, so we get e to the power of minus t on top for the upper limit. Then we have minus e to the power of, plug 0 in for x, so we get minus 2t. Now let's do this problem here. We just turn these functions around and we should get the same answer. So in this case, f is e to the minus t. So we have to integrate from 0 to t, f at t minus x. So we replace t in this function here with t minus x. And we have to multiply it by g of x. So this function now is g. As before, we're just dealing with positive values of t. If t is negative, then the integral is 0. And we know that both u's are equal to 1, so we can forget about them. Here we have minus t plus x, and we have to add that onto minus 2x. So we get minus t minus x. So we integrate e to the power of something, we just get it back. But we must divide by the coefficient of x, which is minus 1, because t is treated as a constant. This makes sense because if you use the chain rule to differentiate, you'll get back e to the power of minus t minus x, but you must multiply by the derivative of the power, which is minus 1. The minus 1 will cancel with this minus 1 here. So we plug t in for x, so we get minus e to the power of minus 2t. Then we have a minus sign. Then we write this down, this time plugging 0 in for x. So this gives us plus e to the minus t minus e to the minus 2t. And that's what we got before. Now we will use the convolution theorem to get the inverse Laplace transform of 1 over s squared plus 1 squared. Here's the convolution theorem. The Laplace transform of f star g is the Laplace transform of f times the Laplace transform of g. We can also write this right hand side as big F of s times big G of s. Now we can write this like this, we can factorize it, and we can look these up in tables. There are functions of this form in the tables. We see that 1 over s squared plus 1 has the form a over s squared plus a squared if we put a equal to 1. So we can see the inverse transform of it is sine of 1 times t. So if we call this f of s and this one g of s, then little f of t is sine of a times t, where a is 1 as we saw. And little g of t is also sine of t. So we are after the inverse transform of f of s times g of s. So we'd have to get the inverse transform of this thing here. Well, that's just f convoluted with g, or convolved with g, and that's going to be the inverse transform of f of s times g of s. So that's the general formula. I just took the inverse transform of both sides. It's just this one is a bit easier to see. So as a reminder, here is our formula. So we need to integrate from 0 to t, f of t minus x, so that's going to be sine of t minus x times u of t minus x, multiplied by g of x. Well, that's going to be sine of x times u of x. And we're only dealing with positive t, because for negative t this is 0. So for positive t both u's are equal to 1. So we know that we can ignore them. Now we have a product of sine functions in this integral, and what we can do is write it as a sum by looking up an identity for it. So we want a product of the form sine times sine. Well, if you go to Wikipedia and type in trigonometric identities, you'll find this one here. So we have to get cos of the difference in the angles, first angle minus second, minus cos of the sum of the angles, all divided by 2. So we can factor the 2 out of this. So I take a half out, and cos of first angle minus second angle, t minus x minus the second angle, and then we've minus cos of the sum of the angles. That's t minus x plus x. Well, that's going to give us t. So we can write this as t minus 2x. Now when we integrate the cos function, we get the sine function. And we have to divide by the coefficient of x. We're integrating with respect to x, so we have to divide this by minus 2. Because if we differentiate, then we use the chain rule. When you differentiate the angle with respect to x, we'll get minus 2, and it'll cancel with this minus 2. Now, since we're integrating with respect to x, cos of t is treated as a constant. So we're going to get this constant times x. Next we plug the upper limit t in for x, so we get sine of t minus 2t, that's sine of minus t. And we plug t in for x here. Then we minus a half times this thing with 0 in for x. So we get sine of t divided by minus 2. And we put 0 in here, we get 0 of course, so we just have this. Now the sine of minus t is minus sine t, and these two minuses cancel, and we get a quarter sine t. Take the half in here, minus half t cos t, minus a quarter sine t. We can add these together to get a half sine t. So eventually we end up with this, and we can put this times u of t because we want a causal function. We just want it defined for positive t. The other way we could have done this problem would be to write this as sum of its partial fractions, where the denominator is s squared plus 1, but because this is quadratic we would have a numerator of the form as plus b, where a and b are constants. The numerator here would have the form cs plus d. We would have to determine a, b, c and d, and then get these into the right form to take the inverse transform. Let's take another example. We can write this function here as 1 over s minus 1 times 1 over s minus 2. So this function here is f of s, and this function here we can call g of s. So little f of t is the inverse transform of 1 over s minus 1. So we look this up here. it's got the form 1 over s plus a if we set a equal to -1. So we put -1 in here, we get e to the minus 1t. That's e to the plus t. And what about g of t? Well, that's got the same form actually. So here a is -2. So we replace a here with -2. We get e to the minus 2t. That's e to the plus 2t. We know that the inverse transform of big F times big G is f star g of t. So let's calculate that. So this is f of t. So we want to get f of t minus x. So we get e to t minus x times u of t minus x times g of x. Well, that's just e to the 2x times u of x dx. Okay, as we said before several times, we can ignore the u's. So we've t minus x plus 2x, that's x minus x plus t. So we get a straightforward integral. We integrate e to the power of something, we get it back. But we have to divide by the coefficient of x. Well, that's just 1. So we just get e to the x plus t. So the upper limit gives us e to the t plus t. The lower limit gives us e to the t. And to make it causal, we just stick in u of t.